All right, number 14. In a sample of 60 students, the mean GPA was found to be 2.7 grade point units. Assume this population standard deviation of 0.4 grade point units. Construct a 90% confidence interval for the population mean GPA. So it's asking for a confidence interval, and whenever we've got a confidence interval, we can either look for a confidence interval for two things, either a proportion or a mean. Well, here it's telling me the mean right there. That's what I'm looking for. So I need to find a confidence interval that looks something like this. The point estimate, in this case, is going to be x bar minus the margin of error, is less than or equal to mu, the population mean, less than or equal to x bar plus the margin of error. Now, why am I using x bar here, not p hat? It's because I'm I'm estimating the population mean. So I'm going to be looking for the mean. So I need a point estimate that estimates the mean. And that's what those are. Those x bars are my sample means. Now, that's what I've got to use to set up the problem. And let's see what else I've been given. Well, I see that I have a selection of some students, in this case a sample of 60 students. I have a mean of GPA of 2.7. So that tells me right there I've got an x bar. It tells me that my x bar is going to be, 2.7. It also tells me that I've got a sample of 60 students. So that means my n is going to be equal to 60, the number of people in my sample. The next thing I've got is assume the population standard deviation. Now, this is kind of taking a big assumption, but the population standard deviation, that's telling me that I've got my sigma. Now, that's the reason that's a big assumption is because we don't typically have sigma whenever you're trying to solve problems like this. But in this case, we are going to make that assumption. So I have my sigma is equal to 0.4. So what's nice about this is once I've identified everything that I have been given, I can just type this into the calculator and get the calculator to tell me the confidence interval. The last thing I need to identify is the confidence interval that I need, or the confidence level. In this case, I want 90% confidence, so I can just use that on my calculator. And when I go to my calculator, I press the menu button, the stats, and then over to the test, because I'm going to be running a test. Then I've got to determine what test do I want to run. I want to run a mean test, some type of a mean calculation, an interval. And I've got two options. I can either run a z-test or a t-test. In this case, I'm looking for, there it is, z-interval or t-interval. Well, because I've been given the population standard deviation, that tells me right there which one I'm going to use. So because I've given the population, I'm going to be using a z-test because I can do this exact thing. So it's going to be a z-interval. I'm not going to show you the picture on the calculator, but I will tell you what I'm typing in. When I type in z-interval, I have two options. I can input the data or I can input the statistics of the data. Well, because I already have my sample mean, my x bar, and my number in the sample and my standard deviation, I'm going to go ahead and move over to stats. When I click stats, it just asks me for my population standard deviation, which is 0.4. It asks for my x bar, which is 2.7. It asks for my n, which is 60. And then it asks for my confidence level, which is 0.90. When I do all that, I press calculate, and I get taken to a screen that looks just like this, or actually gives me output that looks just like this. I get a parentheses of 2.615, comma 2.785. I rounded up that last digit there. I get that x bar is equal to 2.7. That's good. That matches. And I get that n is equal to 60. So what that tells me, this is my confidence interval. That I'm done with the problem. Construct a 90% confidence interval. That is it. Now I just need to interpret this. On the exam, you will be asked to explain what this means. So I'm going to write this out in one kind of long sentence, or one long mathematical sentence. So there it is written in blue. 2.62 is less than or equal to mu, which is less than the 2.79. What that's telling me, this final confidence interval is telling me that the true population mean is between 2.62 and 2.79. So I'm 90% confident that the average student has a GPA between 2.62 and 2.79. That's a pretty powerful statement. I can make that statement about the entire population even though I've just sampled 60 students. That's the power of the central limit theorem. We're going to keep on rolling. Number 16 is very similar to this. It just looks a little bit different in the sense that we've got a different type of situation. In this case, we're having a sample of 18 students with a mean true size of 10.5 and a sample standard deviation of 1.3. That's key here. That sample standard deviation changes things. Construct a 98% confidence interval for the population mean true size. Assume the population true size is normally distributed. All right, so We're asked for constructing a 95% confidence interval. Whenever you're looking for a confidence interval, in this case we're looking for the population mean, we know that we're going to have a final answer of something that looks like this. Some value less than or equal to mu for the population mean, and then some value is less than or equal to that. We're going to come up with these ranges, this range with this lower and higher. Now the calculator will give us that. We've just got to identify everything else that we've been given. So we start off with, we've got a sample of 18 students. That tells me right away that my n, the number in my sample, is going to be 18. That's excellent. The next thing that I can identify is that I've got a mean shoe size of 10.5. Now, you've got two options for your notation for mean. It could be either x bar equals 10.5 or mu equals 10.5. Hopefully you're saying, Mr. Patty, that's an easy question. It's not mu because that's talking about the population. We've been given just the average shoe size for 18 people. That's obviously just a sample, so that's 10.5 based on our x bar. Good. Hopefully you got that. Now, the next thing that's really, really important is it talks about a sample standard deviation of 1.3. That's not talking about a population standard deviation. It's talking about the sample standard deviation. So we've got to make sure our notation is correct, because if you put the wrong notation here, it's going to set you up incorrectly. So my S is equal to 0.3. I'm sorry, 1.3. So that's very, very important, because that right there tells you what type of statistical test are we going to run for our calculator. This right here, I do not have a value for sigma. I don't have a value for sigma, so I cannot use a Z interval test. Instead, I've got to use a T interval test. So I'm going to go ahead and grab that on my calculator. I'm not going to show you my calculator screen, but I'll walk you through it. I'm going to go ahead and press stat, go over to test, and I'm going to scroll down to T interval. When I go to T interval, I've got two options. I can either enter in data or stats. Because I've got the statistics of my data, I'm going to choose statistics. If I was given a list of data, I would type in data and I would put the list into the calculator. I'm going to choose stats. I'm going to enter in my X bar is 10.5. My sample standard deviation is 1.3. My sample size is going to be 18. My confidence level of 0.9. I was wrong. 0.98. I'm going to go ahead and go down to calculate. My calculator takes a second to think, and once I get done with it, it's going to give me it's going to give me the value of 9.714, comma 11.29. Did a little bit of rounding there. And I get that X bar is equal to 10.5. That's good. That matches up exactly what I had. And I get that the standard deviation of the sample is 1.3. That's good. That's exactly what I had. And I get that n is equal to 18. Excellent. So now I've got the output from the calculator. Now I've got to interpret what's really going on. This is telling me this is the confidence interval. So I know that the true population mean is going to be somewhere between 9.71 is less than or equal to the true population mean, which is less than or equal to 11.29. That's the true confidence interval, and that tells me that I'm 98% sure that the population mean shoe size is between 9.71 and 11.29. That's pretty powerful, just based on 18 students that I can make that assumption for the entire population, but that is pretty cool. Last two questions here. I'm only going to solve one of these, and I'll type up the answers for the next one. I want to know the sample proportion and the margin error for any type of confidence interval. These types of problems will follow the exact same way, but if you're looking for the sample proportion, you're trying to find the value directly in the middle of this calculation or this formula. Remember, this formula is always going to take the point estimate, in this case it's p hat, minus the margin of error, and that's going to be in the middle between the true population parameter and then the point estimate plus the margin of error. That's how you can come up with that. In this case, we're trying to find that margin of error. That's what we're trying to identify. We've talked about this in class, but the good thing is anytime you get the point estimate, it's just going to be taking the lower limit plus the upper limit divided by 2. So in this case, that's going to be 0.33 plus 0.41 divided by 2. That's going to give you the value that's directly in the middle. And in this case, that becomes 0.37. To get the margin of error, it's a similar process. In this case, you just take the upper limit minus the lower limit and then divide by 2. So in this case, it's upper minus lower and then divide by 2. Here, that becomes 0.41 minus 0.33 divided by 2, and you get 0.04. Ultimately, that's a very quick calculation, and hopefully you can see where I got those really, really quickly. I'm not going to calculate the last two in long ways on this video, but I will tell you the sample mean in this case is 0.20 and the margin of error is 0.02. You can use those formulas that we've talked about and discovered in class, or you can just kind of reason through it. I think that a lot of you guys can just reason through it in both of these cases. Let me know if you got any questions. You guys are going to do great.